Good morning everyone. The topic we are going to discuss is two-transistor analogy. As you can see, an SCR, which is PNPN device, that can be represented as two transistors by bisecting the second and the third layer like this. The N and P layer in the mid portion of the SCR, that is bisected, and this first PNP constitutes one transistor and this NPN constitutes another transistor. That is, the junctions J1 and J2 constitute one transistor, PNP transistor, that is named as Q1. The second NPN, the junctions J2 and J3, that constitute another transistor, that is named as Q2. As you can see, the anode, which is connected to the upper P region, the current is IT. The gate, which is connected to the mid P region, the gate current is shown as IG. The cathode, which is connected to the lower N region, the current is shown as IK, the cathode current IK. So when you are representing this as two transistors, the first one, the transistor Q1, this is the emitter of the first transistor, this is the base of the first transistor, this is the collector. And for the second transistor, this is the collector, this is the base, and this is the emitter. As you can see, the base of the first transistor is connected to the collector of the second transistor. The collector of the first transistor is connected to the base of the second transistor. That is represented in an equivalent circuit like this. The first transistor Q1, that is a PNP transistor, that's why the arrow is shown inwards. The emitter current, which is equal to the anode current IA. The emitter current IE1 is equal to the anode current IA, which is a thyristor current. As you can see, the collector of the first transistor, that is connected to base of the second transistor. This is collector of the first transistor connected to the base of the second transistor. Then base of the first transistor is connected to the collector of the second transistor. Base of the first connected to the collector of the second transistor. And the emitter current of the second transistor is the cathode current IK of the SCR. Okay. The gate is given to the base of the second, or you can say that the gate is given here, that is to the collector of the first as well as base of the second. So it is shown like this. The gate current is given to this point, which is given to the base of the second and collector of the first. Okay. Now coming to the principle of thyristor operation. As you know, the principle of thyristor operation is when you are giving a positive voltage to the anode with respect to the cathode, the device is forward biased. But if we are not giving any gate current, that is in the forward blocking state. Or you have to give some method to trigger the SCR in order to start conduction, or in order to make it transfer the working from blocking state to the on state. So we are going to explain the principle of SCR using this two transistor analogy. For that, the two transistor model is obtained by bisecting the two middle layers into two separate halves. The junctions J1, J2 represents a PNP transistor and J2, J3, that is considered as NPN transistor. In the off state of the transistor, current collector current IC is related to the emitter current IE using the relation IC equal to alpha IE plus ICB naught. That is that we have learned it in our previous semesters. IC is equal to alpha IE plus ICB naught, where alpha is the common base current gain. ICB naught is the common base leakage current of the collector base junction of the transistor. For transistor Q1, emitter current IE is equal to anode current IA, and IC is equal to collector current IC1. Therefore, for Q1, you can write the equation as IC1 equal to alpha 1 into IA plus ICB naught 1. So, in order to, we have replaced the emitter current by IA because the emitter current is same as IA here. So, for transistor Q2, IC2 is equal to alpha 2 into the emitter current, which is IK here, plus ICB naught 2. This is the emitter current IK. This is the second transistor Q2. Here IC2 is equal to alpha 2 into IK plus ICB naught. And the sum of two collector currents is equal to the external circuit current IA. That we can see from here. This IA is equal to IC1 plus IC2. IA is coming in and IC1 and IC2 are going out. So, you can say that IA is equal to IC1 plus IC2. IC1 we have written as alpha 1 IA plus ICB naught 1. And IC2 we have written as alpha 2 into IK plus ICB naught 2. This is ICB naught 2. When gate current is applied, see here, when a gate current is applied, this is IG. That is equal to IK, which is going out. Then IA is going in. So, you can see that IG, IA and IK are the external currents. So, you can write the currents incoming is equal to the total current outgoing. So, IG plus IA is equal to IK. That is written here. IK is equal to IA plus IG. So, you can substitute this IK by IA plus IG. So, IA is equal to alpha 1 into IA plus ICB naught 1 plus alpha 2 into, instead of IK, I have written as IA plus IG plus ICB naught 2. Now, you can derive the equation for IA from this. See, IA minus this terms with IA can be taken to the left side, minus alpha 1 IA minus alpha 2 IA is equal to alpha 2 into IG, this term, alpha 2 into IG plus ICB naught 1 plus ICB naught 2. Or you can write this as IA into 1 minus alpha 1 plus alpha 2 equal to alpha 2 into IG plus ICB naught 1 plus ICB naught 2, the leakage currents. Or you can write IA is equal to alpha 2 into IG plus ICB naught 1 plus ICB naught 2 divided by 1 minus alpha 1 plus alpha 2. This is the equation for current IA using two transistor analogy. So, by analyzing this equation, we can explain the principle of operation of a thyristor. So alpha 2 is the current gain of a second transistor, Ig is the gate current, ICB01 and ICB02 are the leakage currents of the two transistors. Alpha 1 and alpha 2 are the current gains, common base current gains. So you can learn this equation and explain the principle of SCR, silicon controlled rectifier. For a silicon transistor, the current gain alpha is very small at low emitter current. That is a known fact. We have learned it. For low values of emitter current, the current gain alpha is very small. With the increase in emitter current, alpha build up rapidly. With the gate current Ig equal to 0 and with the thyristor forward biased, alpha 1 plus alpha 2 is very small. Under this condition, forward leakage current is somewhat more than ICB01 plus ICB02. If by some means the emitter current of two component transistors can be increased so that alpha 1 plus alpha 2 approaches unity. As per equation of IA tends to be infinity, thereby turning on the device. I think you have understood this. These are two transistors, Q1 and Q2. If we are not giving this gate current Ig, there is no base current for the second transistor. That means the second transistor is not on. So there will not be any emitter current. If it is not on, there will not be any emitter current. So alpha 2 is very small. If emitter current is not there, this collector current will not be there. That is also very small. So alpha 1 is also very small. If alpha 1 and alpha 2 are very small, using the equation, you can see that IA is equal to alpha 2 into Ig plus ICB01 plus ICB02 divided by 1 minus alpha 1 plus alpha 2. Alpha 1 plus alpha 2 is very small, means the denominator is 1. So Ig is equal to 0 means this term is also not there. So IA is equal to ICB01 plus ICB02, which is very small. So it is in the forward blocking state, in the absence of the gate pulse. In the absence of the gate current, this is in the off state, in the forward blocking state. If by some means the emitter current of the two component transistors can be increased, by some means if we can turn on this SCR so that IE for the two transistors can be increased, then what happens? Alpha 1 and alpha 2 will increase, so that alpha 1 plus alpha 2 is equal to unity. Then what happens is, the denominator of this equation, this will become 0. Alpha 1 plus alpha 2 is equal to 1 means 1 minus 1, this will become 0 and the anode current will increase infinitely. That means the thyristor is on. So the on state as well as off state can be explained like this. The external load will limit the value of the anode current to a safe limit. The method of turning on a thyristor is in fact method of making alpha 1 plus alpha 2 approaches to unity. There are various methods of turning on a thyristor. We will explain gate triggering only. With anode positive with respect to cathode, with gate current equal to 0, shows that anode current equal to the forward leakage current is somewhat ICB01 plus ICB02, that we have explained in the last session. Under these conditions, the device is in forward blocking state. Now, a sufficient gate drive current between the gate and the cathode, if it is given, then what will happen? If we are giving Ig, if we are giving the value a current Ig in the gate, that will drive the transistor Q2 to the on state, and that will drive IC2, thereby Q1 will be on and alpha 1 will increase, so that